Laser. Homojunction semiconductor laser. It is made up of gallium arsenide semiconductor. The principle of this homojunction semiconductor laser is it consisting of a p-n junction diode. When the p-n junction is forward bias, the electrons from n region and holes from p region recombine at the junction of the p-n junction diode, and excess of energy is emitted as light. The type of laser is homojunction semiconductor diode solid state laser. The active medium here is p-type and n-type junction. The laser in which takes place is known as active center. The laser action is there at recombination of electrons and holes. The method used to pump the lower level atom, the higher level atom, is direct pumping with the help of forward biasing. By applying supply of current, we can get laser. Here, to produce amplification of light, we have an optical resonator in which the junctions are well polished. By using this homojunction semiconductor laser, the power output is 1 milliwatt and the nature of the output is continuous or pulsed. The wavelength output emitted from this homojunction semiconductor laser is 8400 angstrom to 8600 angstrom. The conjunction of the gallium arsenide semiconductor laser, here we have a gallium arsenide P region in which holes are majority carriers and gallium arsenide N region in which the electrons are majority carriers. And two electrodes, one is upper electrode is connected to the P region and another one lower electrode is connected to N regions are there. And in addition to that, some switch battery to energize this PN junction diode. The junctions between the P region and N region are well polished. The working. When the PN junction is forward bias. Forward bias means if the positive of the battery is connected to the P type of the semiconductor and negative of the battery is connected to the N type of the homojunction semiconductor laser, the majority carriers holes are repelled by positive terminal of the battery and it enters into the through the junction. Similarly, the majority carriers N region or electrons which is repelled by the negative potential of the battery and it tends to move towards the junction. Here at the junction, recombination of holes and electrons takes place and excess of energy is emitted as light, which is remarkable characteristics, highly directionality, intensity, monochromatic and coherent. That is known as laser is emitted during the recombination of holes and electrons at the junction. In this way, by forward biasing a p-type and n-type, p-type is made up of gallium arsenide and n-type is made up of also gallium arsenide. That's why it is known as homojunction semiconductor diode laser. By forwarding biasing the gallium arsenide semiconductor laser, we can get laser. As we already discussed about that, when the p junction is forward biased, the electrons from n region and holes from p region crosses the p junction and recombine each other. There's a principle used here. The electron in conduction band combines with the hole in the valence band. During that, recombination of electron hole produces in the form of light, here laser light. To increase, to amplify the light coming out, junctions are well polished. Some of the light is sent back due to the reflection of the polished junction. It is sent back again. It is going to collide with the electron in the conduction band and from valence band thereby stimulate the emission of another photon. So thus amplification of light occurs, we can get laser light. This diagram explains about the band energy diagram of p-n gallium arsenide semiconductor laser. Here at the junction during the recombination of holes and electrons we can get laser light. If we have gallium arsenide of band gap energy 1.44 electron volt, with that we can calculate how much of the wavelength of the light energy emitter with this calculation. Here we know that band gap energy is equal to h times the frequency. Also we know the frequency is equal to velocity of light by wavelength. So from this we have a band gap energy is equal to hc by lambda. From that we are going to calculate about the wavelength. Lambda is equal to hc by eg. By substituting the value of Planck's constant 6.625 10 power minus 34 and the velocity of light 3 10 power 8. Here we have for gallium arsenide the band gap is 1.44 electron volt, which is converted as in joules 1.44 into 1.6 in 10 power minus 19 joules. We have the output wavelength of the laser light is 8626 angstrom. It is infrared invisible. The application of gallium arsenide semiconductor lasers are it is used in compact CD to read data, and it is also used in fiber optic communication in which the signals can be converted, all the data are converted into as a laser, and it is used in CD writer. It relieves pain in medical field, and it is also used to print papers in laser printers.